Hello, we are 16s for climate transformation, and we collectively decided to come up with a solution for prompt number 7, consumption and waste. Currently, in many energy cycles, corporations and businesses use a linear model in which there are manufacturers, consumers, and then, of course, waste products. From one end to another, this system is far from sustainable and will take quite a substantial amount of effort to convert to a circular model in which waste products are limited and kept within an enclosed loop, which can be repeated over and over again. One of the largest waste products of this linear system is carbon, which is often viewed solely as a waste, rather than a resource or an opportunity for innovation. What if there is a way to incorporate and recycle carbon back into a new circular production model to promote sustainability?
So 409.8 parts per million. That's the global average of atmospheric carbon dioxide in 2019, and we can safely assume it has not been reduced since then. The amount of carbon emissions trapped in our atmosphere contributes to global warming, which causes climate change, symptoms of which include melting of the polar ice caps, the rising of sea levels, the disturbance of animals' natural habitats, extreme weather events, and so much more. This is where carbon capture comes in. Carbon capture is essentially a means of trapping the carbon dioxide at its emission source, transporting it to a storage location, usually deep underground, and isolating it. This would in turn be a way of reducing carbon emissions, which would be key to help tackle global warming. Research has also shown that carbon capture could reduce global carbon dioxide emissions by almost a fifth and reduce the cost of tackling this climate crisis by 70%. However, most existing forms of carbon capture focus on depositing the excess carbon underground. This system is unreliable as there's no current way of ensuring that carbon stays where it is and does not go back into the air. That is what we aim to change. Instead of a more natural approach, we want to industrialize this practice by creating useful products from captured carbon. This would give major investors an incentive to use their power towards aiding this climate crisis. We would develop new and efficient technology to capture carbon in a more reliable way with the help of these partnering companies. Now, that may sound concerning, industrializing a natural practice, but we need to put things into perspective. Our societies have become more economically developed than ever before, and we need to be able to keep up with this growth if we want to have any chance at making a dent in the climate crisis.
We've been inspired by projects involving carbon capture from all around the world. Globally, there are now 10 new large-scale projects announced, which has been confirmed by the Global CCS Institute. There are also plans to potentially open some plants in the western part of Canada. Countries such as Norway and Sweden have already invested several billions and have already carried out carbon capture projects. Our team thinks that this is crucial not only because we can observe the steps that were taken to make this project possible, but we have evaluated some of these projects and we know we can learn from them, especially by promoting a circular model within them. All of this data encourages us to move forward with our carbon capture project here and shows us that although there are intentions to promote carbon capture, there needs to be a greater emphasis in actually turning the captured carbon into products.
The carbon capture industry as it currently stands fails to effectively incentivize companies to capture carbon dioxide emissions at an industrial scale. Carbon capture has no clear direction for the actual material after extraction, with the current process being to simply bury it, which leaves companies who decide to participate with no actual benefit to themselves. Although the technology itself is promising, it can't truly be scalable without a financial incentive for companies to grow operations to the point that it would drastically impact ambient carbon dioxide levels. There's a gap in the production system specifically with what to do with captured carbon once it's been extracted. We'd like to explore the opportunity of using the carbon dioxide derived from carbon capture to create products with a great potential for people, the planet, and profit. The market for carbon dioxide-based products is one that presents a large opportunity. The industry is expected to be valued at $800 billion to $1 trillion by 2030. Carbon nanotubes in particular present an intriguing opportunity. With a tensile strength that's more than 100 times stronger than steel and more conductive than copper, carbon nanotubes have applications within industries ranging from technology to construction to within the medical field. These qualities make the production of CNTs lucrative, with the demand for them dwarfing the current supply that is being produced, and the market is expected to be worth $124 billion by 2024 alone. Despite the demand, production costs and highly precise production methods have been barriers in wide-scale adaptation into its potential use industries. Recent research, however, has presented a new method for production called molten electrolysis, which improves heavily on the current CVD and polymer pooling methods, while also producing superior quality CNTs. Through molten electrolysis, 1 kilogram of carbon nanotubes can be produced for $50, with a selling price of about $2,000 to $100,000 per kilogram. This process is also extremely efficient with a 1-to-1 exchange rate, where a ton of carbon dioxide produces a ton of carbon nanotubes. By scaling this process to industrial levels, carbon nanotubes now clearly present a high value proposition for interested businesses to further develop this product. Turning captured carbon into solid carbon nanotubes also ensures that there are extremely low risks associated with that captured CO2 re-entering the atmosphere, making the process fully carbon negative. This approach presents a drastic shift in the way that we view carbon emissions. By making the goal of capturing carbon to create carbon-based products to then sell, carbon dioxide now has clear and profitable use cases. While carbon dioxide is often approached as a byproduct of innovation, we believe that it can be used as an asset, a resource that instead drives the future of technological innovation.
Carbon capture has excellent future benefits of companies that choose to invest in it. Carbon capture provides companies with a faster and more cost-effective strategy in hitting internal and government-mandated targets. This is a much better method to reach quotas quicker and cheaper. This also satisfies the public pressure to solve climate change, as it will significantly reduce their footprint. There is a lot of opportunity due to the fact that it is an unexplored market, but CNTs are a very strong material that are highly prized for the creation of important goods such as medical microsensors. McKinsey & Company estimates that by 2030, CO2-based products will be worth close to $1 trillion, and the use of CO2 for producing fuel, enriching concrete, and generating power alone could reduce greenhouse gas emissions by 1 billion metric tons yearly. The Global Carbon Initiative projects that, with proper incentives, by 2030, the overall CO2-based product industry could utilize 7 billion metric tons of CO2 each year, about 15% of our current global emissions. The limitations that previously inhibited corporations are disappearing as more begin to invest in carbon capture technologies. Already, CNTs can be produced close to 100 times cheaper, and research teams have found ways of producing high-quality CNTs without using the extremely stringent conditions that producing it previously required. CNTs have remarkable properties of flexibility, strength, and are lightweight. This makes it ideal as a replacement for metals, strong cement composite buildings, and future applications in industrial catalysts, batteries, and nanoelectronics. These will be vital to future construction projects and have massive applicability in space equipment manufacturing. By using our emissions as a method of generating profit, we believe that this can convince corporations to invest and reduce the CO2 present in the atmosphere. Now, on to implementation. After identifying this area of opportunity, we believe the best approach to scaling the solution is to work with existing carbon capture companies to diversify their end uses of carbon dioxide. We'd like to assist carbon capture companies within North America to begin with to identify carbon nanotubes as an area of product expansion. At the same time, further research is likely needed into creating the process to successfully scale the research from laboratory scale to industrial-sized operators, working alongside research departments to develop a proof of concept is also likely necessary to gain the full support of interested carbon capture companies.
The most problematic linear waste model is our production of CO2. Our solution presents a sustainable economic model for closing the loop on this production of CO2. But why is our solution better than existing alternatives? Well, by industrializing the capture of carbon from the atmosphere, not only do we provide economic incentives to reduce CO2, but we also create useful products and technology that can positively benefit society. These products are long-lasting and ensure that the carbon used will not be released back into the atmosphere in the short term. We must realize that realistically, corporations, governments, and individuals are unlikely to reduce their emissions within the limited time frame we have. By creating a circular model of the consumption and waste of carbon, we reduce the need for these actors to control their emissions. We are honored to have had your attention during this presentation. We hope that you too recognize the need for this new practice. We can make carbon not just a harmful byproduct of industry, but a new means of incentivizing humanity to protect our planet while ensuring our innovative spirit. Thank you.